Welcome to the third video on grade 12 calculus, and we're going to concentrate on first principles or the definition. Right, when the question says from first principles, look for the following formula on your formula sheet. It says the limit as h approaches 0 of f of x plus h minus f of x over h. So we're going to start by finding the gradient or the derivative using first principles and looking at a constant value. So we start by writing the derivative equals, or the gradient equals, the limit as h approaches 0 of f of x plus h minus f of x over h. Important that you stick to the notation. So the limit as h approaches 0, don't get lazy. Then when you substitute the x plus h, you will see there is no x to substitute, so you just write the minus 4 down. Then minus f of x is negative 4, so put it in a bracket, over h. So the derivative equals the limit as h approaches 0, minus 4 plus 4 over h. That gives me the derivative equals the limit as h approaches 0 of 0 over h. Now, very important, that means that the derivative equals the limit as h approaches 0 and 0 over h is 0. Please do not substitute the h with a 0 over here. First say 0 over h is 0. Then in the next step, there is no h to replace, so therefore the limit as h approaches 0 will just be 0. And if you think about it, the gradient of a horizontal straight line, which is the negative 4, so if you think of a Cartesian plane, there's your x and your y axis, and I say f of x is negative 4, that means a straight line that passes through negative 4. And I'll ask you to work out the gradient of that. We all know that the gradient of a horizontal straight line is 0. Then we ask you to find the gradient or the derivative of a linear function. As you can see, 3x minus 4. So we start with the derivative or the gradient equals the limit as h approaches 0 of f of x plus h minus f of x over h. So the derivative equals the limit as h approaches 0. Now f of x plus h means that you replace your x's with x plus h. So you start by writing 3 bracket x plus h, and don't forget about your negative 4. Then it says you have to subtract f of x. So you minus your 3x minus 4. And everything needs to be over h. So the derivative or the gradient, it's the same thing, equals the limit as h approaches 0. Distribute the 3 into the bracket, so you get 3x plus 3h minus 4. Distribute the negative into the bracket, so it's negative 3x plus 4 over h. So the derivative equals the limit as h approaches 0. The 3x minus 3x cancel, the minus 4 and the 4 cancel. So everything without an h will cancel. It's also something you can use to check yourself. Then you have 3h over h. The h's can cancel, so your derivative equals the limit as h approaches 0 of 3. And then there's no more h to replace, so therefore the answer is just 3. And if you look at the graph, it is 3x minus 4, which is a normal straight line, written in the form y equals mx plus c. So it's quite clear to see that the gradient would be 3. Now we have a look at the quadratic equation. So for the gradient or the derivative, the limit as h approaches 0 of f of x plus h minus f of x over h. So the gradient or the derivative equals the limit as h approaches 0. So first start by replacing all the x's with x plus h. So it's 2 times x plus h squared plus 3 times x plus h minus 1. Then you subtract your f of x. So it's minus bracket 2x squared plus 3x minus 1. And it's everything over h. So the derivative equals the limit as h approaches 0. Keep the 2, square the binomial, x times x is x squared, x times h times 2 is 2xh, always positive, h times h is h squared. Distribute the 3 into the bracket, so we get 3x plus 3h minus 1. Distribute the negative into the bracket, so it's negative 2x squared minus 3x plus 1. And it's all over h. Then the derivative equals the limit as h approaches 0. Distribute the 2 into the bracket, so we get 2x squared plus 4xh plus 2h squared. Then the 3x minus 3x cancel, minus 1 plus 1 cancel. So I've got my 3h minus 2x squared, and it's over h. 2x squared minus 2x can cancel, so it's the derivative equals the limit as h approaches 0. Take out h as a common factor on top, so we get 4x plus 2h plus 3 over h. Cancel the h's, so we have the derivative equals the limit as h approaches 0 of 4x plus 2h plus 3. And therefore the derivative, now you're ready to replace your h with a 0. So we have 4x, 2 times 0 is 0 plus 3. You can always check yourself. So exponent times coefficient, 2 times 2 is 4. Write your x down, your exponent becomes 1 less. And then exponent times coefficient, 1 times 3 is 3. The x falls away, and we already know that the constant will become 0. Right, then we can also do the same for the cubic function. So the derivative equals the limit as h approaches 0 of f of x plus h minus f of x over h. So the derivative equals the limit as h approaches 0. Replace all your x's with x plus h cubed plus 9 minus the original function over h. So the derivative equals the limit as h approaches 0. Now be careful with this one. I would write x plus h, and then you have x plus h squared. Plus 9, distribute the negative into the bracket, so it's negative x cubed minus 9 all over h. So the derivative equals the limit as h approaches 0. I would keep the x plus h first, then square the binomial. X times x is x squared. X times h times 2 is 2xh. Always positive, h times h is h squared. 9 minus 9 cancel, so it's negative x cubed over h. The derivative equals the limit as h approaches 0. Distribute the x into the bracket first, so we get x cubed plus 2x squared h plus xh squared. Then the h, so we get x squared h plus 2xh squared plus h cubed minus x cubed, everything over h. Then I can check the x cubed and the minus x cubed cancel. Just going to continue over here. So we have the derivative equals the limit as h approaches 0. I can take out h as a common factor, so I've got 2x squared plus xh plus x squared plus 2xh plus h squared, everything over h. And then we can replace the h with a 0. So we have a 2x squared. That term there will become a 0. We've got a x squared. That will become a 0, and that will become a 0. So my derivative will be 3x squared. And we can double check ourselves. Exponent times the imaginary coefficient is 3. And then you write your x down, make your exponent one less, so it's x squared, and the 9 will become a 0. Then we have our hyperbolic function. So we can have the gradient or the derivative equals the limit as h approaches 0 of f of x plus h minus f of x over h. So we have the derivative equals the limit as h approaches 0. So start by replacing x with x plus h. So it's 2 over x plus h minus my 2 over x, and it's all over h. Now, on top of my line, I am going to find an LCD, which is x and x plus h. So for the first term, I need to multiply by x, so I get 2x minus, and then for this term, I need a x plus h. Now, instead of putting it over h, I'm going to rewrite it as divided by h, and I can write it as h over 1. Then I can say the derivative equals the limit as h approaches 0. I'm going to distribute the negative 2 into the bracket, so I get 2x minus 2x minus 2h. I am not going to multiply the denominator out, so I get x times x plus h. I'm going to tip and times here, so 1 over h. I get 2x minus 2x cancel. So I'm going to just continue over here. So f dash x equals the limit as h approaches 0. So I have minus 2h over x times x plus h times 1 over h. Then the h's can cancel. So I've got the derivative equals the limit as h approaches 0. And then minus 2 times 1 is minus 2 in my denominator, x times x plus h. Then I'm ready to replace my h with a 0. So I get negative 2 over x times x plus 0. And if I simplify that, the derivative will be negative 2 over x plus 0 is still x, x times x is x squared. And if I want to double check myself, I can always write that on top as 2 times x to the minus 1. So minus 1 times 2 will give me minus 2. Write the x, make the exponent 1 less, so it's minus 2. And I can write it as a positive, so it's minus 2 over x squared. Thank you for watching this video. Please remember to like and share. And if there's anything else that you would like us to make, please let us know.